Hi, this lesson is all about the difference between geological resources and geological reserves. To try and illustrate that, I want to show you a diagram. You'll find this diagram on page 22 of your Theme 4 booklets. Okay, let's go. This is the diagram that we need to look at. It's a model. You'll notice there are not really much in the way of numbers on this. So this is a diagram to illustrate an idea. Before we get stuck into the questions here, let's just make sure we can define some terms. Let's start out with a reserve. A geologist would define a reserve as some type of geological material. That could be a mineral, it could be a metal ore, it could be a rock, it could be oil, that we can extract legally, first of all, and crucially, profitably. We only extract resources where the digging them out of the ground is profitable. If not, then they're going to stay in the ground. A resource, then, is a geologically useful material that we can't extract from the ground. Now, that could be because it's not profitable to do that. It could be because we don't know exactly where it is, or perhaps we don't have the technology to extract it from where it's located. This diagram then shows the relationship between these. If you look on the left here, you'll see there's an axis that's called price to cost ratio. The price is how much we can sell a material for. The cost is how much it costs to get out of the ground and to process it. If it costs more to get it out of the ground and process it than we can sell it for, we're going to make a loss. If we can sell it for more than it costs us to get out of the ground, it becomes profitable. And that can be the difference between a reserve and what we call a conditional resource. The horizontal axis on this graph then is our certainty of existence. How well do we know where this material is, in what form it takes, how much there is of it? How much do we understand its geology? Because the more we understand, the more we'll be able to determine whether it's a conditional resource or even a reserve. Now you'll see on the diagram there are lots of different arrows that I've drawn on this. These arrows represent how materials could go from one part of this model to another. You'll see at the bottom of page 22 there's a list of things that would move a resource from one to another. What I'd like you to do is I'd like you to try and match these statements up with these arrows. Okay, number them up. Number each of those arrows to show how each of those things would affect whether it's a reserve or a resource. So press pause now and have a go at that. Okay then, let's see what you've come up with. So the first question was asking you to shade in the area on this diagram where we didn't know where these materials are. We have an idea that they must exist, but we haven't got their location. That's the area. All those hypothetical resources are ones we know must exist, but we don't know where they are. For example, any oil resources in places like Antarctica. The second question asks you to match up the labels uh, of the things that would change the classification of materials from one part of this diagram to another. So the first one is a price rise. Now all of these are focused on oil, but they could apply to other resources as well. A rise in the price will take a conditional oil resource and make it an oil reserve. So if you've got oil that's expensive to get out of the ground, if the price goes up, the cost of getting that out might fall then below the price you can actually sell the oil for, and it goes from being a conditional resource to a reserve. Conversely, if the price falls, we can get reserves becoming uneconomic, becoming loss-making to extract, and they fall into the conditional oil resource section of the diagram. Now, fracking is one way of increasing the amount of oil that we can extract from a reservoir. So if we increase the amount of oil for the same cost of getting it out, that will reduce the cost, if you like, per barrel, and it becomes more profitable. So it could move something from a conditional resource, or one that we know about, for example, and can't get out, to becoming an oil reserve that it is worth getting out. The next ones then are exploration. Now remember, for a geologist, exploration is going and finding resources. That's going to move resources from their hypothetical state either into an oil reserve if it's profitable to get out, or to a conditional resource if it's not profitable to get out. Exploration is the only way we can move materials from being hypothetical to being a reserve or to be conditional. The next one then is directional drilling. Directional drilling is one way of making small hydrocarbon traps economically viable, because you only need one rig to drill in lots of different directions to extract oil from different small reservoirs. So it makes uneconomic traps perhaps economic to extract. Similarly, if we use enhanced recovery, this is where we're pumping water or gas into an oil reservoir to try and squeeze as much oil out of it as we possibly can. That will increase the return and perhaps turn a conditional resource into a reserve. And finally, environmental restrictions. Now these are very, very important in terms of protecting the environment in areas where oil is being extracted. But almost certainly they're going to increase the costs of extracting it, and therefore can move a reserve, certainly one that's marginal, into being a conditional oil resource. So we can see that there are lots of different factors that affect the viability of any type of geological resource. Crucially, we need to think about this balance between the price we can sell it for and the cost of extracting it. But tied in with this all the time is our understanding of the geology. We must understand the geology if we're going to be able to find these things and also to work out whether it's worth getting them out of the ground. And that is our job as geologists.